Assalamualaikum warahmatullahi wabarakatuh to my lecturer, and have a good day. Today I will present about the project 2, the subject surface and aesthetic of machining components. Group 3. I will start my presentation. Okay, this is our group member. The middle one is Danish bin Mohammed Kamarul. The right person is me, Syaful Akiemie bin Syaful Akmal, and lastly at the left, the one and only the girl in our group is Siti Aisyiah. So I will start our presentation with the introduction. The ability of replication molding technically to create micro component and micro features component is continually improving. This is largest driving by customer demands for plastic component with perform of functionality. Surface microstructure can affect the properties of surface, including tribological characteristics such as confusion of friction and wear, appearance and optical characteristic, heat transfer during boiling and condensation, and water replacing. Micro molding is a route to manufacturing microstructure surface. The requirement for scaling micro molding tools to high volume application are the molding tool must be made of durable metal such as steel and be of low cost. This is we move to surface finish. The point 1 will be metal mold structures. In these studies, 6 microstructure experiments were investigated to understand the effect of electron beam irradiation upon very morphology. These structures have been specifically designed to introduce texture and surface functionality into plastic molding components. A breaking of the microstructure with dimension can be seen in table 1. Each surface represent in figure 1. A ceramic is then cased to the microstructure rubber, after which metal is cased to the structure ceramic, resulting in a microstructure must use to impact features of the final polymer part. As we can see, it's at the table 1. Specimen subject to electron beam irradiation. So we can see the material used, sample designation, description, and also the dimensions. Okay, I will move to second point for surface finish is electro irradiation experiment. So basically, a Sodic PF32A ABM machine was used for electron beam irradiation experiments. The irradiation process is carried out in an airtight chamber into which an inert gas, argon, as a pressure of 0.05 Pa in supply. After an initial 10-minute vacuum cycle time, this argon gas is used as the medium for plasma build-up required for the electron generation as beam propagation. The requirement of the EB process, since it is finishing technique and only near the net shape components, will be applicable to this process. The third point for the surface finish is surface character. The measurement of surface roughness was conducted with a Bruker AXX NP flex white light interferometer matrix profilometer and a 50x objective was used to ensure the RA value was not influenced by the surface form of the pillar or any waviness present. Post-profiling process was carried out on the data using the proprietary instrument analysis software. So basically for the surface character is used by the surface roughness machine, so we can find out the result for our project surface molding used by the data, and we can print out the data so we can use for for result surface. So the next slides will continue by Danish. Thank you very much.
Okay, I will continue this presentation. Figure 1, array of moles structures used in this study. Figure label corresponds to designation in table 1. Figure 2, schematic of EBM irradiation process. Surface finish. The project has been successfully created thanks to the CAD and CAM work that has been done, and measurement reading have been collected on each item, particularly on significant elements that have tolerance size, restrictions, and mole connection. However, several components, as stated in the below table, do not meet the standard that have been established. This is our table measurement using caliper digital metotoyo surface roughness machine. So this is our speculasi. Bill number 1, as you can see, on the left side is what we want, and on the right side is our result. So it's not everything that okay. The result: initial trials and graduated parameter. Initial trials were undertaken to establish a suitable process window in which to perform bulk experiment on all samples. These trials were undertaken using processing condition detailed in Table 2. This sequence of conditions was performed on sample square roots. This initial sequence of parameters was investigated based upon previous experimentation on several materials, including CO, CR, MO, TI6A14V, and SS316. The lowest cathode voltage observed to produce any detectable change in roughness in this case was between 10 to 15 kV, usually requiring multiple shots. The sample initial condition is characterized by a variation in top surface roughness with edge appearing sharp and top surface which are undulating. At low shot numbers and moderate cathode voltage, there is little effect on both the form and surface roughness of the rods. However, as cathode voltage and shot number increase, the form and surface roughness are observed to improve. Figure 3. Specimen is subjected to graduated irradiation. Unaffected sample subject to shot at 25 kV, subject to shot 5 at 40 kV, subject to 20 shot at 40 kV. High uniformity, smoothing, and dooming is exhibit in D. The result, morphology and surface finish. Before irradiation, all column tips displayed a degree of variation in both form and surface finish. An amount of the population also exhibit slated surface and asperities. As seen in figure 3 and 5a, it is it is thought that the doom smooth from the column tips will assist with reduced friction involved in the mechanical separation of mold, tool, and polymer part, and therefore less damage to the final part. Although improved final part fidelity to the original intended form would be expected from such mold structures subject to electrode irradiation, it should be noted that this is achieved via loss from accuracy of the shape. No craters can be observed, and both the bottom and top surface have a similarly improved finish. A somewhat improved finish on the sides of the column can also be seen.
This is the result. Surface roughness SPM observation of the sample process using electrode beam irradiation clearing demonstrated an improvement in surface finish that achieved. To quantify the expectation reduction in surface roughness, which is the made possibly by applying technique and non-contact optical surface profiling technique, was selected a mean directly measuring surface roughness (RA). This is challenging measuring as a sample and highly profiling in display many aspect ratio microscale feature. There are four prescaling, the use of stickless-based measurement technique. Surface roughness results are shown in table 4. Final surface roughness achieved on the top of road between 16 nm to 29 nm RA, which is mean 22, approximate 5-fold improvement. This is table 3, final experimental parameter, and this figure 5 domining in initial trial conduct a sample E subject graduate parameter and B sample F subject to 5 plus 24 shoot at a culture voltage of 40 kV. Table 4 show the surface roughness measure from sample before and after irradiation. Figure 5 recenses features on sample C before and after irradiation and sample D before and after irradiation. A significant improvement the surface roughness can be seen approximately and eliminate on the top surface. The surface finish of the button of the smaller features can be improvement. This is figure 5. Column tip of sample of pre A and C to and post irritation B and D. Greater uniformly in elaborated as well and extended domain. This is our summary and description of the article reference. It is demonstration a large area electrode beam irradiation is a superior technique of the polishing design surface manufacture with aspect ratio. In the intent shape of the structure can be improvement in the non-contact approach. that allow potential to be flattened without discretion design surface microstructure. Sign the method quick and need 11 for each electrode per vacuum is the ideal to post value. Micro touch surface roughness is increased from the RA 126 nm to 22 nm without notably regarding the shape. RA increased the initial value of 115 to 27 nm for bottom surface. The approach may be complete. The existing super finishing technology can be nano scale, roll titanium, and it's possible to complete the bottom surface of 20 nm 20 meter diameter dispersion. This is contract to be a supervision. Made other research can raise the material where capturing the typical scene. Thank you to listening our presentation. That's all. Thank you to everyone.